Hello. Team Adapt is delighted to introduce our project FaceLock, a next generation facial recognition technology with OTP for secure banking transactions. This begs the question, why use facial recognition? In today's digital world, traditional authentication methods are vulnerable to hacking and phishing attacks. That's where facial recognition comes in. It leverages the power of deep learning to provide a highly accurate, secure, and convenient way to verify one's identity. Concerned about security? Don't worry. We don't store images. Instead, we extract and encrypt face encodings for storage. Our system uses liveness detection to authenticate genuine users and provide protection from fraud.
Now we want to show you a short demonstration for our website, which includes the journey that a new user would have. This journey starts on the registration page, where they select a username, give in their email address, which will later be linked for OTP authentication, give their account number, and also set a password. As you can see, facial recognition enabled is a checkbox, so the user can choose to opt out, but we will enable this and set a threshold value of 100. The threshold value is the value above which, when a transaction is made, is when facial recognition will be used as an authentication layer. Next, the user will start their camera and take a picture of themselves, which will be used to extract their facial data. Once they see the success message, they are ready to register and can be redirected to the login page. On the login page, the user has to use the same details that they have set during registration, and these will be verified at the backend in order to authenticate the user and log them into the website. They're taken to the profile page, which has the details of the user, including their username, account, and threshold value that they set, and then the user can make a transaction. On the transaction page, the user has to input the details of their receiver, including the receiver's username and the receiver's account number. We're going to set the amount to 1000, which is greater than the threshold that we have set at 100. The first layer of authentication is what follows, which is the OTP authentication layer. An OTP will be sent to the user on their registered email ID, and the user will have to open their email ID and copy this OTP and paste it on our verification page. If the verification is successful, they will be redirected to the second layer of authentication, which is facial recognition. On this page, the user has to capture a few frames of their face in real time, which are used for authentication. We have two models running. The first one is facial recognition, and the second one is a liveness detection as well. We will tell you more about this in the following parts of the video. As you can see, we have the result of match being found and also that the person is indeed real. The user will then redirect to the payment successful page and will see all the transaction details visible.
We continuously tested our website to prioritize user comfort and security. By exploring different scenarios, we evaluated how well our website performed and improved the overall user experience. We have prepared several scenarios to showcase various use cases. These scenarios demonstrate different ways in which the website can be used and highlight its versatility and practicality. One such scenario is when a user is wearing glasses or has something partially covering their face. Our model can still recognize the user and match them with the information in our database. Once the match is found, the user can easily proceed to the payment successful page. A common concern users may have is how aging impacts our model's ability to match their face. However, there's no need to worry. We have addressed this concern by demonstrating a scenario where a user's younger picture was used to match their stored encodings. As you can see, the user held up a picture of their younger self, and this was the face that was captured to check the recognition. We see the matching process was successful. We can extrapolate from this demonstration that our model retains enough distinctive features to ensure accurate matching even as the user ages.
What if your fraternal twin tries to steal from you? Our system performs facial recognition using a modified ResNet model that has an accuracy of 99.83 on the labeled faces in the wild dataset. It performs facial detection first and then extracts 128 dimension facial encodings unique to the individual. Be rest assured they won't be able to steal from you. What if someone misuses a picture of you and uses it to impersonate you and make transactions? Even if the picture was taken in the same location and lighting, our system will be able to detect it. The liveness detection system applies deep learning using a modified VGG19 model to distinguish a person from a photo and identify fakes. It processes the images through 19 layers, including 13 2x2 convolution layers, 5 max pooling layers, 1 flattened layer, 2 dense layers, and 2 dropout layers to ensure authenticity with an accuracy of 99.17.
As mentioned earlier, we give the user a choice to opt in or opt out for FaceLock. We also give the user a choice for setting the threshold. In this demonstration, the user has set an amount such that it's lesser than the threshold, and now the user has proceeded to authentication. As you can see, the user gets redirected to the OTP verification page, and once the correct OTP is entered and the submit button is clicked, we are redirected to the payment successful page, skipping over the face recognition authentication which is otherwise required. To maintain user security, any data we store in a MongoDB database is always encrypted. As you can see, the account number, password, and the user's face encoding is stored in an encrypted format in the user's collection. Moving on to the transactions collection, the account number, the receiver name, and the receiver's account number are stored in an encrypted format. We use SimpleCrypt, Fernet, and bcrypt libraries to encrypt the user data. Thank you for watching our video, and we hope you enjoyed our demo.